Hello and welcome. This is Bijan Hushiar. A switched network with redundancy is created using two Cisco 2960 switches. Both of these two switches are using default configurations, meaning the priority of both switches are the same. No VLANs no VLAN has been created on any of the switches. They're just using the default VLAN, which is VLAN 1. Since priorities are the same, the determining factor in electing a root bridge is the base MAC address of the switch. Let's find out what the base MAC address of switch 2 is. In order to do that, we have to be in privilege mode and perform this command, show version. We do that, the base MAC address of the switch is going to be displayed, which is the one that I have recorded in here. Let's do that for the other switch, switch 1. From the privilege mode, we perform show version, and the base MAC address of it is displayed, which I have recorded in here. To make sure that we can verify that there is no other VLAN except VLAN 1, we perform show VLAN. We notice there is only VLAN 1, which is the default VLAN, is present, and all switch ports are placed in VLAN 1 by default. That's for switch 1. For switch 2, if we perform show VLAN in the privilege mode, we should obtain the same information. Only VLAN 1 is present, with all switch ports placed in VLAN 1. So the default configuration is has not been changed on these two switches. The determining factor in electing one of them by STP as the root bridge is the lowest MAC address. When we compare the MAC address of switch 1 with the MAC address of switch 2, we notice that switch 2 has a lower base MAC address. Therefore, switch 2 is going to be the root bridge, and switch 1 is going to be a non-root bridge. All ports of switch 2, which is the root bridge, are going to be in forwarding mode, and they are going to be designated types of ports. Now STP has to decide which one of the two ports on switch 1 to make the root port, and which one to block and make it alternate port. As far as switch 1 is concerned, it only has one neighboring switch, switch 2, which happen to be the root bridge also, but it is also considered as a sender device, which means frames from switch 1 through the sender get to the root bridge, which happen to be the same device. As far as these two links are concerned, both of them are connected to the same switch. Therefore, the sender uh, MAC address, the lower sender MAC address is the same for both of them. That criteria cannot be used. Both links are connected to the same type of interface, fast Ethernet. The priority of them, the same. That criteria cannot be used. The only difference between these two links is that one of them is connected to FA02, the other one to FA01, two different sender port IDs. FA01 happen to have a lower port ID than FA02. One is lower than two. Therefore, if we trace the link connected to FA01 from switch 2 back to switch 1, you'll notice that it is connected to FA04 on switch 1. SDP is going to make FA04 of the switch 1 root port because it is connected to a lower port ID on the sender side, and will make FA05 the alternate port because it is connected to a higher port ID on the sender side. I had purposely turned the lights off on these links in order to explain this first. Now that I've explained it, let's go ahead and turn the lights on to see if it verifies what we have discussed. It does. Another way to verify what we discussed is by performing show commands. If I go to switch 1 and perform show spanning -3, this information is going to be output, which tells me that the root switch priority is the same as the switch 1 priority. That criteria was not used in electing the root bridge. It also tells me that the base MAC address of the root bridge is lower than base MAC address of the switch 1. Therefore, switch 1 is not the root bridge, it is non-root bridge. Another indication is that we see that FA04 of the switch 1 is the root port in forwarding mode, and FA05 of it is blocked, and it is an alternate type of port. If we perform the same command on switch 2, show span, it tells us that the priority of the root bridge and the priority of switch 2 are the same. That criteria was not used in electing the root bridge. It tells us also that the base MAC address of the root bridge is exactly the same as base MAC address of switch 2. Switch 2 therefore is the root bridge. Another indication is that both FA01 and FA02 ports of switch 2 are in forwarding mode, and they are designated ports, which is another indication that switch 2 is root bridge. So as you noticed in here, SDP blocked one of the ports to prevent a loop from occurring in this switch network that has a redundancy. The criteria it used, the criteria that was used by SDP was a lower sender port ID will make the port connecting to that on the non-root bridge a root port. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.